Welcome to this explainer. If you've ever built an app that required a user to literally sign their name on a screen, well, you already know the struggle. Trying to get a digital line to actually look and feel like a real pen moving across physical paper is this fascinating, kind of frustrating challenge that mashes up user interface design with some pretty complex math. So today, we are going to unpack exactly how the B4XDaisySignaturePad bridges that gap to give you a flawlessly smooth and reliable experience.
You know the exact pain point I'm talking about, right? Why do most digital signatures look like absolute jagged spider webs? The thing is, when you drag a finger or a stylus across the screen, the hardware is just grabbing individual coordinate points on a super rigid pixel grid. If your software simply draws straight, dumb lines from point A to point B to point C, you get these sharp, totally unnatural angles. And worse, the faster a user writes, the further apart those capture points get, making that jagged spiderweb effect 10 times worse. Rendering smooth curves on a grid is notoriously tough, but as you'll see, it is entirely solvable.
We've got a really clear roadmap for today. First, fixing the digital signature. Second, the math behind the ink. Third, mastering the developer experience. And finally, data handling and export. Let's jump right into part one, fixing the digital signature and moving from spiderwebs to smooth ink. Let's actually dive into how this component fixes those clunky lines. When you look at the interactive drawing area, the loops, the varying thickness, it honestly feels like you're putting a real pen to physical paper. That organic, fluid look, definitely not an accident. It requires completely overriding the standard drawing defaults of the digital canvas. And the secret to mimicking that physical world comes down to two properties: velocity filter weight and stroke cap. Out of the box, this component sets a velocity filter weight of 0.7. So what does that mean? It means the software is constantly calculating the exact speed of the user's finger. Just like a real leaky ink pen, moving quickly gives you a thinner line and slowing down lets more ink pool up, giving you a thicker line. It ranges from a minimum width of 1.5 to a maximum of 4.0. You combine that with a round stroke cap, which makes sure the ends of your lines aren't just chopped off flat, and boom, you've successfully emulated analog ink. Okay, moving on to part two, the math behind the ink and the absolute magic of Bezier curves. So since there isn't a native curve tool built right into the canvas, this component brings in the heavy hitter, the quadratic Bezier curve. Now, we're not going to get bogged down in the code syntax here, but just look at the parametric equation. The draw quad Bezier subroutine uses this exact math to map out a perfectly smooth arc between points. It basically takes a start point, an end point, and a control point to naturally bend the line.
This is where the stark contrast really shows up. A standard canvas simply draws a straight line from point A to point B, giving you what the source code literally calls paper-cut edges. Yikes. The B4X Daisy method, though, it takes that Bezier formula we just looked at and slices the calculated curve into 16 tiny, overlapping segments. Then it applies anti-aliasing to absolutely kill those paper-cut edges and dithering to blend the colors. Because the stroke caps and joins are round, it completely fills the microscopic gaps between those 16 segments. That is how you generate a flawless curve and banish the spiderwebs for good.
Right, on to part three, mastering the developer experience. We're talking customization and those crucial UX nuances. Now that the math makes sense, how do we actually implement this? Well, you get total control right in the designer. Because it follows the B4DSC UIKit component development standards, it exposes a ton of dynamic properties. You can flip between semantic border variants, like primary, success, or error states. You can tweak the border radius from totally sharp to fully rounded and stack on shadow elevations. Plus, obviously, you have total control over the ink itself, background colors, pen colors, and dialing in those minimum and maximum stroke widths to get the exact feel you want. But here is an in-the-weeds UX detail that is an absolute lifesaver. Listen, if you've ever tried to sign a form on your phone and your downward stroke accidentally scrolled the entire web page instead of just drawing a line, you know how infuriating that is. This component packs a property called disallow parent intercept, and it defaults to true. When a user touches the pad, this actively tells the Android OS to stop parent scroll containers from stealing those touch gestures. It guarantees your user's signature flow is never interrupted. Finally, part four, data handling and export. Basically, how we move that ink off the canvas. Because a beautiful signature is completely useless if you can't actually save it to your database, right? The export lifecycle here is ridiculously streamlined. It grabs the coordinate points, instantly creates a B4X bitmap object, and then flawlessly converts that image into a base 64 string.
So you're going straight from a visual drawing on a screen to a secure text string ready for your server, all in just a couple lines of code.
And the format flexibility is fantastic. Standard PNG, JPG, or WEBP with adjustable quality scaling from 0 to 100, done. But the really geeky, awesome part here is the BMP export. The conversion uses direct byte array writes, including a highly specialized method for little endian 32-bit integers. Why should you care? Because it means there is zero dependency on random access file. It's incredibly lightweight. Oh, and it packs a built-in is-base64 method using regex to validate strings, so if you're loading a signature back in, you know the data isn't corrupted.
There's also this incredibly clever target pad concept. By using this set-bitmap method, you can seamlessly copy the live data from an active input pad directly over to a synchronized read-only display pad. Imagine an enterprise app where your customer is signing on one half of the screen, and the finalized, locked-in signature is instantly populating a secure review document on the other half. It's just a brilliant workflow. So when you combine the genius math that completely kills those jagged edges, the really thoughtful UX safeguards against accidental scrolling, and that lightning-fast data export, how is this going to elevate your next enterprise project? You literally have the tools to create a flawless, analog-feeling digital signature right at your fingertips. Thanks so much for tuning in to this explainer.